Example 4 says a 26-foot rope is attached to the top of the flagpole and reaches the end of the flagpole's 10-foot shadow. So that rope is attached from the top of this flagpole and goes down to the end of the shadow. So this here is 26 feet. Okay. How tall is another flagpole? So again, we want to know the height. If, at the same time, it has a shadow of 12.5 feet. Okay, right now we only have one pair of corresponding parts. Okay, we need to find another pair of corresponding parts. That will help us find out how tall this second flagpole is. Okay, now, what I see here is I see a right triangle. So we can use the Pythagorean theorem. We can say that the height of the flagpole squared plus 10 squared is that hypotenuse of 26 feet squared. When we work out our Pythagorean theorem, the height of this first flagpole ends up being 24 feet. And so now, since we want to know the height of our second flagpole, and we have the height of our first flagpole, plus we've got another pair of corresponding parts of the similar triangles, now we can set up a proportion. Okay? Just like we did in examples 1 through 3, height of the first flagpole corresponds to the height of the second flagpole, and the shadow of our first flagpole corresponds to the shadow of our second flagpole. We cross multiply. 10 times x is 10x, and 24 times 12.5 is 300. Divide both sides by 10. And our second flagpole with a shadow length of 12.5 feet ends up being 30 feet tall.